Good morning, good afternoon to everyone, all the ETAPians, as well as our esteemed customers and guests joining us across the globe. Thank you for taking time out from your busy day. I'm sure in next 25 to 30 minutes, we will explore some of the greatest disruptive technology that we are bringing in for operational technical training applications. When we talk about operational training applications as an OTS, it's not new in the industry. However, this has not been really explored for the power application. So today we will touch base on all the disrupting functionalities that we are bringing in ETAP using a digital twin model for the power systems training simulations for sustainability and efficiency. With that, my name is Sheikh Shahid Hussain. I work as a Senior Vice President and Global Director of ETAP based out of Dubai office. And let's get started. So let's understand what is the need of operational technology systems or the OTS application.
Are you a part of the electro-intensive or electro-sensitive industry? Is power critical for your business or operation? Do you know what accounts for the maximum dollar losses per incident within your industry? Is it design error, process upset, or equipment failure? It's none of these. It is operator error. Surprised? As per one of the industry reports, operator error accounts for the highest dollar loss per incident every year in the process industry. 40% of unplanned shutdowns occur due to operator missteps. Operator errors occur due to the following: readiness of the operator for malfunctions and emergencies, floor plan contingencies, inability of the operator to predict system behavior before actual implementation, relying on automation without any validation, and many others. So the question is, how to save these millions of dollars every year? Is there a solution available to train the operators on actual systems and prepare them to handle these pressing issues in real time without making an error? Yes, there is. ETAP has the right solution to provide your operators and engineers with an effective learning environment to improve and augment their knowledge of the actual power and process systems by using ETAP's Digital Twin platform. Save hundreds, thousands, or millions of dollars by minimizing CAPEX on new design or upgrades, startup time reductions to reduce overall OPEX from improved system efficiency, reliability, safety, and availability resulting from improved operator skills. eOTS, the Operator Training Simulator from ETAP, is a model-driven power system training simulator which helps to develop and improve operator competency through real-world simulated learning. eOTS can integrate with your existing electrical automation infrastructure without even having to replace your legacy system to provide real-time simulation. Accelerate dispatcher operation training by implementing eOTS.
As we hear through, the operator training simulator is a must requirement from a business perspective to reduce the downtime. Let's look at more from an operational drivers. What exactly it is required from an operational perspective in order to have an OTS. So let's say you have new staff and you wanted to train your new people with the factory and facility. You don't have time or the platform to do that. So eOTS is a must necessity in order to have the right training. You have unusual disturbances that you wanted to support in understanding the power system behavior for the future expansions or the networking equipment changes, doing often startup of new plant or doing a black stat applications, creating the latest and greatest expansion on the digital technologies, as well as knowledge transfer and sharing within the systems, and also to essentially understand and predict the behavior of the machines in the electrical format, and which is basically the requirement of operational drivers to have an OTS. As we speak about the operational drivers to have the OTS, there are also the requirements by the operator itself. We as an engineer, we as an operator, we wanted to be empowered. We wanted to be in the control of our facility. We wanted to know how the plant behaves. We wanted to have a right conditioning to the prediction of our system operations that we are going to do perhaps 1 hour later or next week or next year, with respect to startups, shutdowns, and creating various simulations. We would be in a position to perform various forensic analysis. We have to be secure and safe by itself. And that's what is basically the desire of an operator, to be empowered in order to take the ownership of the facility and convert all the crisis to the opportunity and begin the train the trainer kind of concept. So many facility owners invest a huge lot of money on training their operator, but those are essentially theoretical training, go to some of the programs and come back, and so on and so forth. And what, we have spoken to many operators, and what we have heard from them, that they go and they do the training, but they forget. When they see it, they remember, but when they do it, they really understand it. And that's where we are saying that these are the key drivers and the requirements for the operator, to empower them with the operation technology applications with respect to the operator training simulator. As we speak, the OTS is based on ETAP Digital Twin platform. Many of you are already aware of how the ETAP Digital Twin is being combined right from the designing to the operational maintenance phase. Let's look at a little bit on the same journey as we are moving from the design to operation in an integrated manner. So, be it a greenfield project or a brownfield project by in-house engineering team or by the external consultant contractors, you create an ETAP model which has all the ID and relay settings. You perform various power system studies like load flow, short circuit, relay coordination, and so on and so forth, to the electromagnetic transient simulations, along with core simulations environment. And in the same time, you have a process model which is being done through the process modeling and simulation tool. So as we are moving in the process of designing and creating a basic design digital twin as an ETAP, which has all the physical, electrical, and characteristical attributes of the component, including its O&M information, we essentially graduate the same model from a designing environment to an operational environment, all the way through the factory acceptance test, commissioning, and startup process. So imagine you have a model which has been done, and now you are doing for a startup management or commissioning management. You can take the same model and do the commissioning setup and the validations, or doing a factory acceptance test and the startup validations with the actual equipment with software in the loop configuration. And eventually, the same digital twin, once it is being tested and validated, it goes into an operational digital twin convergence, and that's where it connects to your existing SCADA, PMS, or EMS system, or ETAP becomes by itself on SCADA, PMS, and EMS systems, where it gets all the real-time data from the field equipments, like so the generator, to the meters, to the relays, to the breakers, to the loads, all the real-time sensoring data which is available in the SCADA PMS gets transferred to ETAP, same model which has come from the design basis, and converts into an operational digital twin model as an electrical DTS, dispatcher training simulator, or operator training simulator. And once getting the real-time data, it can replicate and mimic all the functionalities of the SCADA, PMS, and EMS in order to define various numbers of operational scenario, which is being configured in the scenario wizard, where you can define the trainer and trainee configurations for any kind of conditional approach in order to provide the right training and understanding to the operator, and which essentially provides you various situational awareness and analytics by means of the real-time analytics. And eventually, most of the process facilities or the electro-intensive facilities, they have the process OTS, which comes along with the DCS system. So ETAP also integrates with its strategic partners such as Aviva to provide an integrated power and process OTS applications. And that's where you can see a 360-degree of digital twin with power and process applications. And once you have an OTS which has in the real-time environment talking to either native SCADA of ETAP or PMS of ETAP itself, or any other OEM SCADA platform, now it is available with providing all the real-time analytics and having a situational awareness for the operators and the maintenance and management team on a continuous basis. So this is basically a journey of ETAP, right from the design to operation and maintenance, using a unified model, unified database, converging from a design to an operations, and that's what we call as a digitization journey with ETAP. It not only gives you an OTS, but also sets a foundation for your digital transformation of all the existing assets. As we move forward, ETAP eOTS comes along with a very structural platform with a high fidelity software and hardware in the loop, which is essentially communicates on a native protocol such as IC61850, DNP3, Modbus, or OPC, or IC101 or IC104 to any existing SCADA PMS or any existing historian or enterprise database systems. It may be a DCS system, it may be a SCADA system, it may be a enterprise database like OSI system. ETAP can interface natively into all of this infrastructure of automation system, or in a greenfield project, ETAP becomes an SCADA, PMS, and EMS by itself, and populate all the data, which includes the network model, topology, and the real-time data from the field, and eventually map all of those informations to the ETAP OTS system, where it creates a software and hardware in the loop in order to take the network topology and build the scenario which is being given by the trainer in order to converge those scenarios and populate the responses which is being coming from the trainee, to have the right feedback from the system's behavior as per every conditions which is been defined in the scenario, so that an operator or a trainee or a trainer can have the real look and feel of the systems without really doing any kind of operational functions on a live system. So they are getting trained on their live system without really doing any kind of control management or the change management. And this is applicable across the industry, right from the electro-intensive to electro-sensitive, from extra high voltage of power generations to the extra low voltage of the power distributions, from mission critical facilities like data center, hospitals, to the transmission distributions, to the renewable applications and the smart grid, and obviously oil and gas and other industrial customers. So you can, ETAP is adapted to all the technologies which is available to be integrated and available for all the different economic sectors to fulfill the requirement of electrical OTS functions. So the way the electrical OTS occurs with respect to the functionality, it provides the complete steady state and the transient and the dynamic responses, along with all the protections, safety, as well as remedial special schemes, including the power quality. But most importantly, it provides an plant virtual representations as it is operating in the real environment, along with the full-blown functionality for the SCADA and power management, energy management, generation management, load shedding validations and management, DER, distributed energy resources, microgrid and smart grid applications, transmission and distribution, ADMS, DTS functionalities, and so on and so forth, which is essentially getting trained, as it is a model-based platform. It gets trained over the data of which is coming from SCADA, all the historical data and all the analytical data, to essentially provide you the right approach on the plant behavior in that point in time as it would be happening. So these are essentially the functional applications. As I said, it comes along with a trainer and trainee environment, where you have a trainer actions in order to define various training scenario. A trainer can create any kind of conditions of the plant, in an ad hoc condition, or it can create any kind of predefined sequences, such as injecting and signal tripping, or defining and increasing and decreasing of a load, addition of renewable sources, islanding connections, and so on and so forth, and which scenarios will be issued to the trainee, and trainee can perform the actions in order to start the responses of the operations, including the opening and closing of the breakers, doing various generation management and regulation set point functions, or going for the load shedding management or calling for a fast microgrid or unplanned controller functions and so on and so forth. And as the scenarios are converging, every single steps are getting recorded along with all its alarms, events, status, so that at a later stage, once all the actions is being done by trainee in order to overcome that situation which has been issued as a scenario from the trainer, it can be reviewed and it can be corrected to provide the right understanding for the switching procedure or the operational management for the training. So this is a real 360-degree electrical operational training portfolio for doing a consecutive training and yet preparing for the better operational strategies for the plant owners and operators. So, as I mentioned earlier, it is a high fidelity power simulations for both steady and dynamic analysis. So, ETAP takes the data from any OEM agnostic environment, communicates to all the PMS and SCADA systems and gets the real-time data, historical data, which comes to the ETAP OTS, essentially the instructor machine, and that's where it creates all the different scenarios and issued the scenarios to the trainee, and essentially trainee takes the predefined operating conditions and takes all its action for the right operational mix and gives the feedback to the trainer, where trainer opens all this and play it back to evaluate the trainee performance or correct the operational approaches as required basis as per the rule book of the facility that it is being operated in. And with that, the operator can have multiple scenarios for multiple trainees, and there would be a complete conglomeration of the real data, historical data, and the simulated as well as the corrected data by the trainee into the systems to provide an integrated training assessment and the scenario management in overall basis. And that's what is the definition of the data flow and logical flow of the system. So now let's look at how this OTS digital representation comes in. In a typical scenario and environment, you have various logs, status feedback, TMS, EMS, and supervisory control systems, which is being connected to one standard SCADA or power management systems in the control center model, and you have all the telemetry data and the historian data which is available. So what happens, ETAP essentially comes along with software in the loop power simulations environment, where we create a digital twin power model, and that digital twin power model has all the representations of your source generator modeling or your load modeling, all the protections and the metering modeling, which essentially connects to the data acquisition layer of all these supervisory control systems, and then take the real-time data and have the system events, which is basically goes into an OTS environment to create different scenarios and sequences which is being required for the OTS functions, and then it converts the steady and dynamic simulations for the response back, and essentially converging the field elements as it is required, let's say for a generator or load or just open and close breaker feedback conditions and so on and so forth, and upgrade the topology and the data processing and network management the way it updates in your SCADA system, so that they feel that this is a complete true copy and replica of OTS. So main foundation is the advantage of the digital twin along with the feedback response and the software in the loop, which gives and helps to provide all integrated platforming for such kind of scenarios. So as we move forward, the model integration is as follows, which is again little bit detailed into it. We do have the network model where we create all the electrical model. Then we have the generator model, including the dynamic models of the governor, exciter, TSS, and obviously all the load models which is available, including any kind of induction loads or the standard steady loads, and those all converts into one PQ and IV, which is basically the generation priority and the frequency model. And we get the reference of the PF and IV, and those all information goes from various IEDs, metering data points, to the telemetry model, and all the events, which includes the network topologies, goes there, and it basically provides an integrated approach in order to have the understanding of actual behavior of the systems, and the model convergence inside OTS, where it does all the simulations and goes in a closed loop format again to recreate all this network topology and scenario based on the events which has been defined by the trainer and trainee, and conducts the dynamic response. So that's how you can have a complete detailed model of your system and the plant, and understanding of their behavior in the same time. So typically, if you look at in any industry, if they already have an automation systems where you have various field IOs, edge controller devices, sensoring elements, which is basically monitoring to the breaker, relays, IDs, meters, and getting the real-time data, goes to the PMS, EMS, and smart grid control functions, and then you have the SCADA, HMI, and actual in the control room. What ETAP essentially does is takes the data directly and natively from the existing SCADA systems of the real environment, and that online data converges into the ETAP OTS with all the functionality. All the field IOs and their response actually comes into a software in the loop dynamic simulations, and that converges the response and the behavior and the feedback without really doing any field IO, or any kind of controls block diagram changes. And that's where the SCADA HMI response gets exactly the same the way it would have got from the real systems, so where it have the similar representations and the feedback in the ETAP OTS SCADA HMI, and that really creates a virtual control room. And with the approach, you are actually representing the real systems into the digital world, and that's where the combination comes in to combine the field equipment and the real-time informations into a digital informations without need of any programming or any kind of configurations other than just native connections and the software in the loop, where there is an identical representations for all HMIs, all SCADA screens, alarms, events, actions, responses of the dynamic systems to various actions, and so on and so forth. So this is a virtual digital twin model of the plant facilities as we speak on. And moving forward, as we have spoken earlier, along with our partner, we do provide a combined power and process OTS, where there would be an process OTS where it looks at the process parameters, the mechanical equipment, all the pressure and temperature, and creates the process simulations and the dynamic training management in the process side. We have one core simulations which integrates with the electrical side with ETAP, where ETAP does the steady and dynamic simulations and the detailed network modeling at the ETAP site, and they do provide a convergence together with one core simulation approach, where the validations of various systems and on-site generations can be done. All the electrical systems operations with respect to the process dependencies can be identified and implemented well, or the overall process and power losses and outages would be identified, and you would be having all the coordinated electrical systems integrated along with various process critical facilities together, which basically provides you an integrated unified power and process OTS along with a core simulation approach. With this, as we understand the overall systems and the behavior, the approach is as follows, where, let's say, as an example, you have an existing systems with some of the SCADA and HMIs, and which is already in action. The same is represented in ETAP as it is. So as you can see, the replicability of the system visualizations is just the same, for exactly the same for the EMS systems to the various representations of the GMS system from an existing systems to the OTS, and all the turbine control management system, generator control management systems are replicated as it is. All the capability curves are represented as it is in the existing system versus in the OTS, similar for the load shedding applications, and so on and so forth. So with that, we come to end of eOTS. Let's try and see what eOTS supports in the industry challenges, solutions, and the benefits. So The first and the foremost concern is avoiding the unplanned outages, which is being caused by the operators, which is the human errors. So in order to reduce the risk associated with the owner's mistakes, or doing any wrong switching mechanism, or doing performance productivity with safer operations, and so on and so forth. ETAP OTS provides the right platform in order to simulate in the digital twin model, do the validations, create various switching processes, performing a predictive approach to verify the actions, and creating a dynamic simulations tuning, which basically provides an integrated switching action and control logics together, and simulate the systems, train the systems before you deploy it, and in the same time creating all your new stuff and the aging stuff for the training of the platforms, or the shift in charge of new projects or the new facilities. It obviously helps in supporting the startup and commission times in order to ensure your successful and smooth startup and shutdown processes. Understand all the simulations of sequence of operations and the hardware and software in the loop, along with the factory environment as well as in the site environment, to reducing your commissioning and downtimes, and finally bringing the operator awareness and readiness for operators to be prepared to use seamlessly one model all the way from the design to operations, and handing over from the EPCs to the operating companies on the same data fabric, same model, without any need of handover or transition, which becomes a very self-learning and deep integrated non-intrusive environment, and you are actually using one platform from design to commissioning purpose, and eventually hand over all the knowledge to the customer, and that gives you the complete reliability and compatibility of the systems and the flexibility. So with that, the digital twin journey, as I said, once you have done the overall electrical designing, you have an as design model, and essentially you take the as design model and do all the simulated conditions where you bring in all the software in the loop model, and that essentially converges into an ETAP OTS environment where it integrates with the existing SCADA or new SCADA of ETAP or any other OEM, and creates all the operator training environment as it is. Essentially, you when it goes to an operational environment, you have all the operating stage which goes to the SCADA, you get the conditions and create as operated, and here ETAP brings in as operated to an as validated. You validate the system before operations in the operation conditions, and then eventually you deploy the control as required into the field. So this is essentially the whole journey from design to the software in the loop validations, to the factory acceptance test, to the SCADA, to the OTS, and actually deploying in the real operational scenarios. So what is it required? It's really a change management for the operations, for adaptability of the new task, existing system extensions, operating procedures, new control systems, defining all the different operational management and knowledge development for the smart operational techniques, prediction of the diagnosis of faulting early enough, dynamic network knowledge, bringing the engineering efficiency and the empowerment of the operators by means of providing them the validations tool for their decisions, creating all the power control logics, what if applications, and the training by itself for the plant owners, plant managers, obviously supports in the revenue downtime reductions and increasing of the revenue, plant safety management, knowledge engagement, and so on and so forth. And finally, making the operator more empowered as an just not an operator, but as a power systems trainer, and having the complete control of the facilities and the plant in his fingertips. And that's what typically is an operator training simulator from ETAP. In summary, what we are saying is ETAP eOTS empowering the operators to make the better decisions via realistic training approach, as well as providing the situational awareness. So fundamentally, it has a lot of benefits, but if we have to categorize it, the first one is obviously providing the training where you can have ad hoc predefining training scenarios for your new engineers, shift in charge operators, in order to understand how to operate in case of contingency, in case of changes and challenges, and generally upgrading their skill set. That's the first fundamental. The second fundamental is the predictive simulations and analytics, where operator can do any kind of expansion, what if scenarios, are they need to real, in order to support their decision making process, and also help in the FAT and commissioning validations whenever you are doing the deployment of the system. So before you have a real-time systems, you can actually create a replica and digital twinning of the systems in order to validate and seamlessly execute the commissioning, execute the project and do the commissioning and hand over to the users. And finally, it brings the switching prevention and management, where you can have one before doing any kind of control or executing any kind of command, operator can have a peace of mind to do the simulations, get the feedback, and create a situational understanding of the systems, whether they would be having power balance or not. And if yes, what would be the switching procedure and the work order procedure that they need to follow. So this just not only fulfill the training part, but also the plant safety, operability, expandability, as well as efficiency as per the long-term sustainability and change management as required basis. With that, we are at the end of this session. We hope it will have been some good learning and information to all of our ETAPians across the globe. Let's see, we have few questions which has come up during the presentation. Let's see if we have certain questions that we can answer today, which has been arranged. Number one is, does ETAP OTS is an integrated systems or it's an independent system? Yeah, answer is ETAP is a part of large ETAP enterprise applications, which is completely modular. It works on the same ETAP digital foundations as integrated manner. However, ETAP OTS can be worked as a completely independent autonomous system, or it can work as an integrated ETAP ecosystem solutions. Can we apply ETAP OTS for all the industries? Yes, you can deploy eOTS for any industry wherever you have power systems. This can be deployed. Does it show all the functions of existing TMS, EMS? Yes, it depicts and emulates all the functions as well as look and feel of existing automation systems, right from the SCADA to power management to load shedding to generation management to disturbance management to distribution management to operational management systems, and so on and so forth. Thank you very much.